Hi everyone, thanks for joining us for the webinar today, the DevOps 2.1 Toolkit. Just a couple of quick things up top before we get started. We are able to take questions. There's a place where you can ask them right on your control panel. Eric Long is on the line. He'll be helping answer them as we go, and then if we have time at the end, we'll be able to take a few on the air. We'll be taking them all offline as well, so if anything comes up that we don't get to, which that very well may happen, we'll be taking care of it later on. Excuse me. There is a chat option as well, but usually the questions panel is easier to use, especially if you do have a question. It'll be much simpler to take care of it. We are recording this, so that will be made available later on. And without further ado, our presenter, Victor.
Thank you, Max. Okay, so today I'll be speaking about some of the DevOps tools and practices, in particular about continuous deployment using Jenkins and Docker Swarm. A very quick introduction. My name is Victor Parsik. I work for CloudBees. We are a company behind Jenkins, open source and enterprise. I'm one of the Docker captains, so I'm very close to both of the technologies I will be speaking today. And I published a couple of books. I'm not going to do marketing today, except to say that the material from this webcast is the second book, the DevOps Toolkit 2.1. So, the subject of today's talk is a combination of Docker, continuous deployment, and Jenkins. Why would we use those two tools in one process, and how can we combine them into something more meaningful and hopefully helpful? So I will assume that most of you already know what Docker is. So I will not go into details today, except to say that it's becoming a huge ecosystem with various components. One of them is Docker Engine. It's application that allows you to run our containers. Docker Machine is a way to create virtual machines provisioned with Docker in a very easy, lightweight, and fast way. Docker Compose, a way to declaratively define arguments that we would normally use if you would run Docker commands from command prompt. Docker Registry, a place where we store images. And finally, the star of today, together with Jenkins, is Docker Swarm. It's a tool we use to orchestrate containers in clusters. So I will start bashing some code right away. Later on, I will give you the address of the presentation so that you can repeat if you want the same commands I'm going to run today. So I don't have much time, so I will go relatively fast, and hopefully you will pick up. So at the moment, I have a couple of machines set up on my laptop. And nothing else. That's the only thing that I did before starting this meetup. So I'm going to change my Docker client to point to one of those machines and run something called Visualizer. This is not something that you should really run in production, but it will help us visualize the state of our cluster relatively easy. So with Visualizer, this is how our cluster looks at this moment, meaning there is no cluster, there are no servers in a cluster, it's completely empty. So I'm going to start and bring up the first node into our cluster, join through cluster. The command is relatively easy. Docker Swarm init, give it the address of a node you want to join the cluster, and that's about it. It's as simple as that. So I initialize my cluster with the first node, the only node at the moment that we have. And if you look at the visualizer one more time, you can see that my cluster consists of a single server. This is usually not enough, and we want to have at least a couple of more servers in a cluster so that it really looks like a cluster. So what I'm going to do is I'm going to run Docker Swarm join, give it a token. It's a security token that prevents anybody joining the cluster. Give it the address. Added address is the address of the server that will join the cluster, and finally the address of one of the managers, the first node that enter the cluster. So now, two more nodes join the cluster, and I have a cluster of 3 servers. As you can see it here in the visualizer, 3 servers, my cluster, still nothing special. If you don't like UIs, you can run docker node ls, which will give you the list of all your all nodes in your cluster. In this case, I have 3 nodes: Swarm 1, Swarm 2, Swarm 3. All of them are at the moment managers. One of them became leader, the first one, and the others are reachable and would become leaders if the first node fails. So let's start with creating a registry. Now this is the first service I'm going to create, and this is a new thing. It appeared in Docker 1.12 a couple of months ago. And now we can create services by simply saying docker service create, give it some name, expose some ports, in this case 5000, and I'm going to mount a current directory on my host to be available inside of this service as varlib registry for persistent storage of images that I'm going to push there. Finally, I'm going to reserve 100 megabytes of memory, and the image is called registry, right? That's the first step, simply because throughout our CDP process, we need a place where we're going to store things that we build. And Docker Swarm immediately responds with acknowledgement. Does not tell us whether things are already running or no, just that it understood the command. So if you want to see more details about the service, we can run docker service ps and name of the service, in this case registry, and you can see the desired state is running and current state is already running for 15 seconds. Now this is one of the things you should understand, is that unlike some other cases, especially if you run Docker before, directly through Docker engine, we're not telling Swarm what to do, but the desired state. And you will see the effect of the desired state very soon. So the desired state of this service is to be running, and indeed current state is matching the desired state. It's already running for quite some time. Now if I go back to the visualizer, you will see that Swarm put our the service somewhere inside of a cluster. It happened to be on Swarm 1, on node 1, but it could have been placed anywhere else. Once we start operating with clusters as a single unit, it becomes irrelevant where it goes. That's not our job anymore to decide where we put services. Rather, schedulers like Swarm or Kubernetes or Mesos take care of those things. They know simply better than we do where should we deploy our services. So let's see next. Now I'm going to start creating a bit more of a services, but before I do that, I'm going to create 2 networks. One is called proxy, and the other one is called GoDemo. I'm not going to explain in much details networks now, because we're going to see them very soon in action. So I'm going to wait until a few more slides. The only thing important is that two networks were created, and if I list all my networks, you will see you can freely ignore local, that there is a Swarm network GoDemo, Swarm network proxy, and the third network ingress, which is created by default whenever we create a Swarm server, and has a special purpose that we're going to discuss very soon. So the moment I have 3 networks in my cluster. So the next one, I'm going to create a service of a service that we're going to, after it's created, we're going to move it throughout the continuous deployment pipeline. But before we start with the pipeline, I need to have a service running inside of my cluster so that I can create new releases, among other things. So it's going to be simple. It's going to be Docker service create, same thing as before. I'm going to give it a name, GoDemoDB. I'm going to attach it to a network, GoDemo. And the service itself is called Mongo. Now this is database, obviously, that will be required by the service that we're going to develop very soon. Now, what is important to note is that I did not expose any ports. In most cases, with Docker Swarm, you don't have to expose ports. And as a result, this service is inaccessible to anybody except other services that belong to the same network. You will see very soon. So let's see. Sorry for that. Another service. I'm going to create this little, I think the last service I'm going to create. So it's Docker service create, again, GoDemo. I'm going to pass environment variable DB with the value GoDemoDB. Now you should understand that the service that I'm about to deploy, to create, the code of the service, which is written in Go, but it's not really important, will try to connect to the database using the value of this environment variable, right? It does not know the IP of a database. It does not know where it's running. The only thing that the service needs to know is the name of the other service it needs to connect to. So I'm going to attach it to the same network, attach it to additional network proxy. We'll see very soon why. And finally, the name of the service is GoDemo. And that's about it. So let's create it. This is a third service. And the last one. So if we look at the visualizer from before, you will see the Docker Swarm distributed services across the cluster, right? One is running in Swarm 1, the other one is running in Swarm 2, the third one is running in Swarm 3, right? As we start scaling the services, you will see that things are going to get a bit more complicated very soon. But at the moment, this is just enough. We don't care about destination of our services. Swarm distributes it evenly across the cluster, right? So if you want to see the process of a service, let's say GoDemo, it's already running in Swarm 2 and for 27 seconds. Very good. So finally, the last piece of the puzzle is that since none of the services is exposing any port, we need to make the GoDemo service, which is the backend service that exposes an API, available to the public. And one of the ways we can do that is by creating a proxy, like we would do with or without Swarm. This is a bit special proxy, but I will not go into details now. You can check the project from Dockerflow proxy on GitHub. The only important thing to understand is that the proxy will be the first service that opens any ports, in this case 8080, 443, and 8080, which is internal port, not really relevant. The first two are really important because they will expose FTP traffic to the cluster on ports 80 and 443. So the service is created, and if I go back to the visualizer, you can see that Swarm decided to put it on the node 2. Right, so finally, what happens if we ping a service, right? Let's see. So, yeah, so if I ping a service, it already works, right? Now, important thing to understand, if you remember from up here, the proxy is running on Swarm 2. And I tried to ping, to send a request to the service on Swarm 1. What happens is that Ingress Network kicked in, meaning that once you expose the port to a service, to outside world, as proxy does, that port becomes available on every single node of the cluster. One of the reasons behind such a decision is fault tolerance, so that you can actually have any server of your cluster as an entry point. And even equally important is that Ingress Network will redirect from any of the servers, requests from any of the servers into the destination service, in this case, proxy. And not only that it will forward requests, but it will do load balancing, which is not currently the topic, but if I would have multiple instances of the proxy service, the networking, Docker Swarm networking will do load balancing. But since the main subject is continuous deployment, I'm going to move towards the next subject very quickly. This was just a very quick introduction into Swarm. We can speak about, just drop me an email if you want more information. Just you should know that we can create services and they are distributed across the cluster. So continuous deployment, right? In theory, very easy thing to understand on logical level. We check out some code, run some tests, build something, run functional tests, push the result of what we built to registry, deploy to production-like cluster, run production-like tests, and repeat the same process on production, deploy it, run it, right? I'm pretty sure that almost everybody knows, in theory at least, how it goes. It's relatively simple. It becomes much more complicated in practice, but as a process, very, very easy to digest and understand. Now, in my case, I have extra requirements, right? It's not only doing those steps that you see or they might vary from organization to organization, but in my case, it needs to be more than that. And that means that I need to have freedom to code in any language. If we are moving towards microservices, that means that we're going to have different teams, each of those teams, different set of requirements, and they should have freedom to choose the language they want to code, because there is no more one language that rules them all, depending on what you want to accomplish. Sometimes Node.js would be a better fit than Java, or maybe Go or Python. No matter which language you use, you should have freedom to use it freely and deploy your stuff without any interference. The same can be said for frameworks, right? I don't want to be tied to a specific framework decided by organization I work in. I want to be able to choose freely not only the language, but frameworks I want to use. I really don't want to depend on infrastructure. You know, the situations, especially in large corporations, when you need a new server, then you open a Jira ticket, wait for a couple of weeks or a month, and you get it, or you don't, depending on how your infrastructure department works. Another important thing that I think that it's very important, we have immutable deployments, because without immutable deployments, we don't know whether what we tested in one environment will be the same as what we are going to deploy in another. Test one set of artifacts in or configuration combination in integration environment, deploy to production, doesn't work. Why it doesn't work? Because we are not deploying the same thing as what we tested. With immutable deployments, that's very unlikely to happen, simply because what we are deploying is always the same, no matter whether we are talking about our laptop, testing, staging environment, integration environment, production environment, and so on and so forth. And finally, not finally, I want really minimum time in between steps. Everything needs to happen very fast. If your continuous integration delivery deployment process takes a whole day, that stops being continuous, right? We should aim for very high speed, like let's say 10 minutes, maybe 15 minutes would be the maximum acceptable period of time between for this process that I'm proposing to finish. And the reason why it must be so fast is that if you're going to trust the system, that means that when we finish a feature, we commit our code to repository, we have just enough time to grab a coffee, and if it fails, we get a notification and get back to fix it. Because once we start working on a new feature, going back is a very expensive operation. Our brain cannot really do multitasking and switch from one context to another. So those things need to be so fast that we don't have enough time to that we get the failure notification before we finish the coffee and start working on something else. And finally, freedom to innovate, which is a combination of all those things. The reason why I have those requirements is that I'm very impatient. You might notice by the way I talk. I really dislike handovers. I don't think that we as industry should continue in the direction of having departments where I finish my part of the job and give it to you, you give it to somebody else. We should work more like a self-sufficient teams where without any handovers. I just like depending on others. It's, I guess I'm a social or something like that, and really it's like doing the same thing over and over again. Now we can accomplish all that with containers, because containers gives us immutability. They give us ability to package everything instead of only packaging a jar file or bar file or whatever you're using to package. We have the whole stack, everything that is fully immutable and can be moved throughout the whole life cycle with relative ease. So that brings me to Jenkins. Now, most of you already use Jenkins, probably, so I'm not gonna go in details what Jenkins is. You probably already know that it's a tool for continuous integration. It's a tool that you can use for continuous delivery, continuous deployment. You can use it to orchestrate everything you want. It's very awesome, ultimately awesome, and that's about introduction for Jenkins. It's awesome. So let's start immediately with running Jenkins inside of a cluster. Now, you're probably, those of you who already do use Jenkins, you probably have a dedicated server where you run your Jenkins master. You probably have a couple of other dedicated servers that you use for Jenkins agents, and that's simply how we were doing things in the past. but that has quite a few deficiencies. One of them is what happens when your Jenkins fails, right? If it's running on a dedicated server, then you're in real trouble when it fails because you need to create a new server, start it somewhere else, and so on and so forth. Now, if we leverage what I quickly showed you with operating service in a cluster, we can use the same logic for Jenkins, right? Instead of deploying it on a specific server, I can deploy it somewhere inside of a cluster. I can do that by repeating a very similar command like before, Docker service create, give it some name, reserve some memory, open a few ports, those ports that Jenkins needs, in particular 8080 in container. I'm going to expose it as 8082, which is the Jenkins port that we're going to use for the UI, and 50,000, which is the port for agents. Couple of options. I'm going to mount this directory on my host so that I persist Jenkins home across all the servers. And finally, I'm running Alpine version of Jenkins. Why Alpine? Because it's smaller, much lighter than normal Jenkins version, because it's not based on Debian, but Alpine Linux, which by definition is very small, maybe 2 megabytes to 3 megabytes, something like that. So I got immediately acknowledgement for Docker Swarm that Jenkins is running, and you can see already that Docker Swarm put it on node 1, right? It's immediately running on one of the nodes of the cluster. And if you don't like UIs, we can process of the service, Jenkins in this case, and you see it's running in Swarm 1 and running already for 18 seconds. It's that easy, right? And the reason why it's so easy is because we are leveraging two things. First of all, containers. Everything is already packed in a container, so I don't need to think about it too much. And I don't need to think about dependencies, what to put on my infrastructure. My servers have all in Docker Engine, that's about it, right? Everything else is a container. And finally, we are leveraging Docker Swarm to make sure that our service is running somewhere inside of a cluster. Now, before I proceed, let me double check that the Jenkins is really working. I'm going to open its UI. Let's see. Yeah, it is working. Now, if you already used Jenkins 2, you might know that there are some manual steps that needs to be performed during the first setup. One of them is to put administrative password, which I'm going to do right now, and install some of the plugins. This will take a minute, hopefully. Okay, the first one is finished, second, third, so on and so forth. This is the only manual really action I'm going to do today. There are ways actually to automate installation of Jenkins 2, but since this service is created only once, I did not go into such length to automate this part of the setup as well. So, and since I'm going to use Jenkins pipeline today to demonstrate how everything works, I will not need any special plugins. The only special plugin, apart from those that come by default, is going to be Jenkins Swarm, which has nothing to do with Docker Swarm, but it will allow me to run Jenkins agents in a very efficient way. We're going to set it up very soon once the rest of the 6-7 plugins is finished. Six more to go. Come on. I'm getting impatient. I already said that I'm a very impatient person. Okay, 4. 3. Okay, I'm gonna set up my administrator password. Admin, full name is admin, and my address is admin.acme.com. Now, also please notice that since I already quickly explained how Ingress Network work, now Jenkins is running in Docker Swarm. It can be accessed through any of the servers in a cluster. It doesn't matter whether it's really running on the same node or not, simply because Docker Ingress Network will redirect the requests. So the only thing missing before I can start using Jenkins is to install Jenkins Swarm plugin, my plugin of choice to run agents. Okay. Okay, and this is the last plugin. Okay, now I'm ready to I have a fully operating Jenkins. Now let's see what would happen if I kill Jenkins. I'm going to run docker rm command, which will be a simulation of what would happen if Jenkins server stops running, or even if the whole server gets destroyed. What happens is that if we go back to visualizer, Jenkins already was removed. It's not in a cluster anymore, simply because I removed it forcefully. And a moment later, Swarm already detected the failure of one of its services and ran it somewhere else. In this case, it ran it on Swarm 3. There's a difference between being imperatives, telling Swarm what to do, and declaring desired state. And since the desired state of Jenkins in this case was to be running, Swarm is doing its best to make sure that that is happening all the time. And if I go back to Jenkins, even though I destroyed the instance, even though the disaster happened, Jenkins is still running, right? I just need to log in again. Now, before I start running any jobs in Jenkins, I need to create agents, right? For those of you who don't know what agents are servers, let's say, where actual jobs will run. So I'm going to create a directory workspace on my server, and the only thing I'm going to do now is one more time Docker Swarm init. So I'm going to create a second cluster, right? Because I don't want to really run builds and tests and all those tasks on my production cluster, so I'm going to create a second cluster. That second cluster is created in the same way as before, Docker Swarm init, the address of a server. I'm going to run visualizer again so that you can see how my cluster looks like. It looks like this. My second cluster that is used for testing is at the moment only one node big. So how can we run agents? Now again, even for that, we can leverage one of the commands, so one of the Docker service commands. I'm going to repeat everything the same as before. Docker service create, give it some name, some command options, mount some directories. But what is really important here and new is I'm going to run it as global. When service is global, it means that it will run on every single node of the cluster. And we don't need to scale it up, scale it down. If it's a type of service that we want to run absolutely everywhere, this is the way to go. Just specify mode global. And when it's mode global, when I list service process of my service, Jenkins agent, it's running on Swarm test 1, because that's the only server that currently belongs to my second cluster. And if I open my Jenkins UI, you can see that the node is already registered by itself. I dislike doing 3 things from the UI. I like command prompt. So this is the benefit that Jenkins Swarm plugin gives us. It auto-registers agents inside of a master. So now, what would happen if I would want to add more agents to a cluster, right? And the only thing I need to do is to add more servers to the cluster. I'm going to create a directory again, and I'm going to run Docker Swarm, join another server to the cluster. This is the 5th server, second server in this cluster. Give it IP of a new server and tell it which cluster to join. Now, since I declared that my agent service is global, if you look at the processes of the service, you will see that this service automatically runs on the second node as well, simply because it's global and it's already running for 3 seconds. So I added, in a very easy way, additional agent my Jenkins master. So right now I have 2 agents running and ready requests. So let's see. Now that my Jenkins master is running, it is fault tolerant. It will run no matter what happens. I have agents that are running in a way that they are very easy to scale up and down just by adding or removing nodes. I will add a couple of environment variables. One of them is going to be the IP of my Swarm production cluster. I like to use environment variables simply because they allow me to reuse values across all the jobs. So I'm going to declare prod IP and prod name. I think that's the variables. Yeah, prod name. I'm going to call it Swarm1. So this is just indication for Jenkins, where is my production cluster. This is the address of the cluster where it should deploy stuff. Finally, now I'm going to create a registry as well. I'm going to do it very fast simply because it's the same registry as before. And I'm all ready. Now, before I create my continuous deployment pipeline, just to quickly clarify, because people get confused, what is continuous deployment, what is integration, what is delivery. The continuous deployment is very easy to explain. Every single commit that goes through a fully automated pipeline and is deployed to production. There are no humans involved in a process. If there are humans involved in a process, then we're talking about continuous delivery, or more likely continuous integration, because there are some manual tasks to be performed afterwards. In case of continuous deployment, everything is fully automated, no humans. There are no exceptions to the rule, except when a pipeline fails. And if a pipeline fails, then obviously humans need to fix the bugs, fixing infrastructure, whatever the problem of the failure is. But unless there is a failure, we are out of work. So the same steps as before, just in this case, in a fully automated fashion. So I'm going to create a Jenkins job. To do that, I need to open my Jenkins instance. Where is my Jenkins instance? Here is my Jenkins instance. I'm going to create a new job. I'm going to call it Go Demo. It's going to be a pipeline. I cannot interact with you guys, but I hope that you're nodding with your head saying that you're already using pipelines, because if you're not, I really recommend, because pipelines are much better option today than freestyle jobs. And I'm going to add to the pipeline this script. Now this script, there is not much time to go into details, but I'm going to use Docker for every single step of my pipeline. So first, I'm going to check out, except checking out the code. So I'm going to check out the code. This is my repository. This is the service. This is the code where the code is residing. Now I have a unit stage. This is where I'm running my unit tests. So I'm going to run, in this case, I'm going to use Docker Compose that defines all the tests required for this stage. I don't need to install anything on my infrastructure. I don't need to install anything on a server simply because the tests are happening inside of a container. And with the exception that source code is going to be mounted into it. And this opens really great opportunities, because suddenly you can leave your teams to define a team that is developing a service can define, okay, this is the container, I need Node.js, I need Golang, no matter what. This is the container I want you to run as unit tests, and we can end up having a not only fully automated pipeline, but also pipeline that is the same for every single service or a project we have, as long as we have certain naming convention. Naming convention can be that Docker Compose file that defines the commands is having a service called unit. So after my unit tests are run, I'm going to build the Docker image. And then I'm going to move into staging phase. In the staging phase, I'm going to run staging dependencies. And again, this is now a bit more complicated than before because unit tests are relatively easy to run. We run them against static code. For staging phase, we cannot simply execute some tests. We need to prepare run all the services required for those tests to be successful. In this case, it's a relatively simple service, so this staging dep service in Docker Compose will bring up the service that I just built, and on top of that, it will bring up also create a service that runs MongoDB because that's one of my dependencies. So once my whole staging environment is up and running, I can run my staging tests. This is very similar to unit tests, just different set of tests. And the major difference is that this time my tests are going to run against the live server with all its dependencies. Now, for a very good, I put all this in a try-catch finally block, and the reason behind that is that I want, no matter what happens, whether those tests are successful or failed, I want to stop all my containers, to remove all my containers from running and free resources for something else, right? So that's the reason. If I didn't put it in a try-catch finally block, then if these tests would fail, my pipeline would stop, and I would not have opportunity to remove those containers and free the resources. Since it's in finally block, this part will be executed no matter of the success or failure of the previous steps. Then I'm going to push my my image. Once I run staging tests, I have more or less confidence that my service is really tested well. I'm still not 100% sure, but very close to that. So I can push the result, the image that I built previously, to registry and make it available for others to use. So I'm going to tag it and push it to the registry. Further on, I would run some tests in a production-like environment, but since my laptop has a limitation of how many clusters I can create, I'm going to skip this part for now. And imagine that happened, and I'm going to run it in production. Now I'm going to run it by executing Docker service update. This is a command that I didn't do before. And in a nutshell, what the Docker service update does is that it updates a service that is already created. So in other words, we create a single service only once in a lifetime, and every single time we want to change something about that service, we run Docker service update command. In this case, the change I want to perform is to run a new release on top of it. So I'm going to run release 2.1, build number of my job, as a new release of GoDemo service. And the good thing about this is that if I would scale my service to a couple of instances, not only that Docker service would update my release, but it would do it in a rolling updates fashion so that there is no downtime. It would update one instance, then wait a bit, update another instance, wait a bit, and so on and so forth. And throughout that process, the worst case scenario is that 1 out of n number of instances would not be running at any given moment. In the worst case scenario, I would get some maybe performance penalty, very small. And finally, once my service is upgraded, I can run the last set of tests. That is again Docker Compose, and run production tests as they're defined in Docker Compose. Now, from the perspective of somebody who creates a pipeline, you don't really need to know about the details, what is inside of all those tests. The team that created the service knows that. They created the service, they wrote the code, so they know what tests they need to run. As long as there is some naming convention, we are all fine, and you can run the same pipeline no matter how many applications you have. So let's see, I'm running out of time slowly. Let's see whether this works. I'm going to run my, usually doesn't work from the first attempt. So let's see. Let's see the logs. I'm running my pipeline. It's fetching data from Git. Now it's going to run unit tests. You can see that it's download. In this case, service is written in Go, so it's using Go image, Go Docker image as the base image. Next is going to download all the test dependencies, and that's among other things is going to be MongoDB. Likewise, if you don't like looking logs, you can just see the progress using the stage view inside of Jenkins. That gives you a bit more eye-pleasing display of what's going on. My connection is very slow today. I'm apologizing for that in advance. This normally shouldn't last this long. Still downloading my dependencies. Okay, so it finished with MongoDB. They're running the rest of the libraries required for tests, and it's finished. And you can see that all my tests passed, right? Those are unit tests at the moment, and they're all successful. I'm ashamed of myself. I'm a very bad coder. I did only 3/4 of test coverage, but I guess good enough for this demo. Then it built the image, and it built it using Docker file definition that defines everything that my application needs. After the image was built, it runs staging dependencies, meaning that it ran MongoDB and the service that it built, and those two services together were tested again. Staging environment. All my second set of tests was successful, right? Once the second round of tests is finished, it stopped all the containers to free us for something else, and proceeded to the next stage. And the next stage was to push it to the registry, so the image is available for anybody inside of my organization, and updated my service in production with the new release 2.1. And once the update is finished, it ran the last set of tests that validated my service in production, whether it was really not only deployed, but whether it was integrated well with the rest of my services. So let's take a closer look at what happened. And if I list the processes of the Go demo inside of my cluster, you can see that the old release was shut down. It was running on Swarm 2, and the new release was brought up, in this case on a different server in Swarm 1, and this is the release 2.1, and it's already running for a minute. And that's about it. I know that I was very fast today. It's very hard for me to judge whether you're sleeping or really listening to what I'm saying, because I cannot see you guys. So I'm gonna part with this. If you're interested in books and this topic, please take a look at them. And I think that we are now open for questions. I think we have 15 minutes for your questions.
All right, Victor, we've got a couple questions. One of the questions from Sergey is there an official image with pre-installed default plugins to avoid installing plugins at the service launch?
There is no official image with pre-installed plugins as far as I know. Eric, please correct me if I'm wrong. But it would be fairly easy for you to create your own image. It would probably be like 15 minutes job to create your own Docker image with the plugin that you really need.
That's correct. And I know with the 2.x installations of Jenkins, the core plugins are actually part of the installation file, so it doesn't need to download them. So it is a little bit faster to get those installed. But yes, you could
That's
always install it and get it all up and running, and then create a image from there. Okay. This one I'm not sure if I understand it correctly from James. Any reason to use the Jenkins agents over the lighter, more scalable Docker agents?
No, those agents that I run as Docker containers, and inside of that container is Docker client. And Docker client and Jenkins Form. Jenkins Form allows me to register agents automatically in a master, and the Docker client, of course, to run the rest of the containers. That image exposes Docker socket from the host so that containers are not running inside of containers, but on the host. Now, this is definitely not the only way to run it. There are probably like 100 ways to run Docker Jenkins agents in Docker containers. It's just the way how I like it, simply because I can expose it as a global service and take care of my agents on a nodes level instead of some other ways to do it. But it's just a personal preference, nothing else.
Okay. Person named, I believe, Ruslan was asking if you can elaborate. The question was, how did Jenkins mount get replicated to all the nodes? Is this a feature of Docker Swarm?
No, it's not a feature of Docker Swarm. In this case, I did a bit of a trick because I'm running it on my laptop, and servers that form the cluster are Docker machines, and Docker machines expose mount automatically directory from the host from my laptop. So actually, they're the same directory. My users directory is available in every single node of my cluster. Now, in a real-world situation, in real production setting, you would do it quite differently. I mean, logic is still very similarly. You would mount an NFS volume on every single server of your cluster, and then when a service speaks with a directory on the host, that directory would always be the same, simply because it would be always the same NFS volume. And this is a simplest possible solution. Now, if you want to go further, you might want to check something, tools like Flocker or RexRay, and there are quite a few more that do a quite more sophisticated way of managing distributed volumes than NFS would be. But in this case, I just use the trick because I run this on my laptop and don't have an NFS server.
All right, sounds good. A few people requested if the actual text of your commands are going to be available.
Yes, I'm gonna post the address on the chat. I don't know whether this is a public chat or no. Or I'm gonna, Max, is this a public chat where I post it?
It appears you sent it only to the organizers. Here,
Okay. Organizers and panelists. Okay, sorry, I'm not very good with technology.
I passed it along.
Now you have it in multiple copies. So these are the slides of the presentation, so all the commands are there. Just be careful, the presentation, since I'm a nerd, goes in 4 directions, so you need to go left and right, up and down. Left and right are major subjects, and up and down are details. So as long as you follow the arrows, you should be fine. And feel free to send me an email at any time, and I will give you any help you might need.
Great. One question that wasn't necessarily directly what we're looking at now, but always comes up and is a good question when it comes to this is, how do you manage production credentials?
That depends. If the question is tied to Jenkins only, or is a more general question. If it's Jenkins only, then there are quite a few plugins that handle your secrets within Jenkins. If the question is more general and not directly only related with Jenkins, then you might want to use some of the tools like Vault from HashiCorp. That's one of the solutions that is open source. There is enterprise version as well, but you can start for free with that. You can manage your secrets in a very relatively reliable way. Nothing is 100% sure, but so it would be a server where all the secrets are always cached and require special keys to be accessed. Next question.
All right. I've got a question from Cheryl. They're saying they have a production environment with over 100 servers. How is the Docker image deployed to all of them?
Docker image is not deployed. First, let me make a distinction. Docker image is something we build, and once it's running, it becomes a container, right? So Docker Swarm will first decide where the service will run, and then it will pull those images on all of the servers, all of those servers. So if you run 3 instances and Docker Swarm decides to run it in 3 out of 100 servers, it would pull the image on all those 3. Now, if the question is where to pull it from, then you have quite a few options. One is, of course, Docker Hub. That is it can be public or private, and it's somewhere in cloud. You can run your own registry, like I did, private registry. It's a completely free option. And then there is secure registry, secure private registry, which is a paid version from Docker, and so on and so forth. There are quite a few solutions where you store it. It's similar to the process if you use Java, what you would do with Nexus, just on a containers level.
Okay. Someone was asking your thoughts on the Docker Slave plugin that was just released.
Docker Slave that was just released, I haven't checked it yet. So I must say that I have a very, I know it more or less. I discussed it a lot with Nicholas, which is the author of it, but I still haven't had, I had very little time to try it out, so no comment yet.
Is that Nicholas Delouf?
Yeah.
Oh, that's right. I do remember talking about. Okay. He's Nicholas is another CloudBees guy, and yep. I think our other Docker captain, right?
Yeah, he's the second Docker captain from CloudBees.
Oh, wait, maybe he's the first Docker captain. And you're
no,
well,
absolutely not. There is absolutely no way that you can claim that.
Okay, so I hope I'm pronouncing the name correctly. Dejan or Dejan. Quick comparison between Swarm versus Kubernetes versus Mesos.
Okay. Kubernetes started long before Swarm, and it's based on Google Experience. So, so simply because it exists for a longer time, it has more features than Swarm has today. However, the differences in those features are getting smaller and smaller every day. And I think that very soon, feature-wise, those two products will be the same. On the other hand, I really think that Swarm shines in its simplicity. I think that what Docker does is always very simple and easy. So if you look for something that makes sense from day one, Swarm would be my choice. If you can invest eternity to learn a product, then Kubernetes would be a good choice as well. And the third one, Mesos, personally, I don't like it. I think it's kind of oldish, but I promise I'm not going to speak bad of any of the products, so that's about it for the explanation. And my preference goes for Swarm simply because I think that it moves much faster than any other product, and it's much simpler.
Okay, thanks. There's a question that says, do images downloaded for tests, like Golang, can they be reused, or will they be downloaded during each job?
No, it will be reused. So whenever there is a command to run a container, no matter whether it's in Swarm or not Swarm, Docker Engine would verify whether that image already exists on a host. And if it does, it would use the image on the host. And if it doesn't, it would download it. So it would download it only the first time. Swarm goes a bit further. So instead of only checking whether the image is there, it would check from the repository whether the image changed So if the image is not there or it changed, it would be downloaded. Otherwise, it would be reused from the previous execution. And also,
Great.
even when you download the new image, you download only parts that changed. So even when you change something, you download only a few layers, not everything.
Okay. The DevOps 2.1 toolkit book covers both Docker and Docker Swarm. Oh, they're asking if it does.
Yes, it covers both Docker and Docker Swarm, with the special attention on Docker. Sorry, on Swarm. Yeah, it's covering both of them, and it's dedicated to those two. That does not mean that there are no other tools in the book. There is Jenkins, there will be Elasticsearch, Kibana, Prometheus, many other things. But the star of that book is Docker Swarm and Docker, of course. The Docker and Docker Swarm are the same thing. Now they're unified in the same engine. So there is no real separation between the two.
Okay. Let's see. It looks like we've got 2 minutes left. We'll do maybe one or two more questions. Sergey has a question. It says, when Docker Compose is running the integration test, if it fails and the pipeline destroys the containers, how the developers are intended to analyze and reproduce the problem? Should they run Docker Compose outside of the pipeline?
That's a good question. No, I mean, they could, but what I didn't show here, because I tried to limit the scope, is that I tend to ship all the logs from any of the server, no matter what's happening, in a central location. It can be Elasticsearch or any of other free-search databases. So my logs are always shipped into a database, and they can be accessed from there. That simplifies the process greatly, because then you don't need to think about, oh, where is my service running on? This is the server. And then you find out that actually the fault is not in a service, but in something related to a service, and you need to spend quite a lot of time running from one server to another when you run inside of a cluster. So I always ship my logs, no matter whether that's production or testing, into, in my case, Elasticsearch, but you can use any of the other products of similar purpose. If you would not ship it to a central database, then the command that I executed that says Docker Compose down should be removed and replaced with Docker Compose stop. You would stop containers but not remove them from the server.
All right. I think we're at the top of the hour. Max, I'll hand it back off to you.
Yes, thank you everyone for staying on, asking a lot of really good questions. Thank you, Eric, for helping with those questions. And of course, thank you to Victor for putting on the presentation itself. A lot of good information. Just a reminder, we were recording this, so we will be getting the recording out to you soon. And we are aware that there are many questions that were asked that were not answered. And so we will be figuring out the best way of getting those answers to you, of course. But for now, we're going to end to be, wary of people's time. We are at the top of the hour. So thank you very much. If you have anything else that comes up, I believe Victor did say he gave out his email. I am marbuckle@cloudbees.com as well, ARBUCKLE. So feel free to be in touch, and we will get back to you shortly.
Quick note, I just posted my email on chat, so guys, if you have any questions, feel free to send me an email.
Yes, I'll leave it open for another minute or two so that you can see the email address before I close out. Thank you again.
Thank you.